Section 5.4, Solutions and Applications of Right Triangles. This section is going to be a review of right triangle trigonometry. The emphasis is going to be on applications or word problems. So first, let's quickly review what a right triangle is and how to properly label one. A triangle in which one angle is a right angle, which is 90 degrees, is called a right triangle. If you scroll below, you will see that I have a little schematic of a right triangle. And remember, in a right triangle, you're going to see this little square, and that square or corner indicates that that particular angle is 90 degrees, and so that the triangle is a right triangle. Okay? All right. The remaining two angles in the right triangle are acute, which means that the measure of each angle is between 0 degrees and 90 degrees. And as far as labeling the triangle goes, we're going to focus the attention on one of the two acute angles. It doesn't matter which one, but whichever one we pick, we're going to call it theta. Okay, so we've got our right angle. The other two angles are acute. Okay, so we've got this angle that is definitely between 0 and 90 degrees, and then we've got this other angle that doesn't necessarily have the same measure. Okay, so I'm going to use a different color here, but it is acute as well. Okay, so out of these two acute angles, we just choose one and name it theta. So the green angle is the one that I have labeled theta here. Okay, and based on this angle theta, that is how we're going to label our right triangle. Okay, so if you go up, it says relative to theta, and that is important. Relative to theta, names are given to the lengths of the sides as follows. The side opposite, which means across from theta, is called the opposite side. The side across from the right angle is called the hypotenuse. The hypotenuse is the longest side in the triangle. It is typically labeled C, designating that it has a length of C units. And then the non-hypotenuse side adjacent to, which means next to theta, is called the adjacent side. All right, so again, when you're labeling the adjacent side, the opposite side, and the hypotenuse, it's all relative to theta, okay? So when I look at theta and I go straight across from it, okay, that is going to be the opposite side. Okay, so this is the opposite side that I have labeled in blue here, okay? And then if you go directly across from the right angle, that side is going to be the hypotenuse. Okay, so this red side, I'll color it purple. Okay, that is the hypotenuse. It is going to be the longest side in the triangle. Okay, and then the remaining side is the adjacent side. Okay, so it's considered next to, but again, if you have trouble identifying the adjacent side, just find the opposite side, find the hypotenuse, and then the other side has to be the adjacent side. Okay. All right, so remember, if you're dealing with a different angle, if you're looking at the blue angle, for example, okay, relative to that angle, okay, maybe this is alpha, this would be the opposite side, okay? It's all relative about which angle you're talking about, so keep that in mind, okay? All right, so based on these definitions, okay, for a particular angle, we define the trigonometric functions of theta. Okay, the trigonometric functions of theta can be expressed as ratios of the sides of a right triangle and are defined as follows. The sine of theta is equal to the opposite side over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. The tangent of theta is the adjacent side, it's the opposite side over the adjacent, okay? We can also say that it's the sine of theta over the cosine of theta, okay? And then the cosecant of theta, it's 1 over the sine of theta. So basically you're just flipping the sign, okay? Sine is opposite over hypotenuse, so that means the cosecant of theta is going to be the hypotenuse over the opposite. The secant of theta is 1 over the cosine. So similarly, we need to go flip the cosine. Okay, cosine is adjacent over hypotenuse. So if we do a switcheroo, the secant of theta will be the hypotenuse over the adjacent. And then finally, cotangent of theta, it has the most definitions. It is 1 over the tangent of theta. It's also the cosine of theta over the sine of theta. So essentially we're just swapping or flipping the tangent. Tangent is opposite over adjacent, so if we flip that, we'll get that to compute the cotangent of theta. That is going to be the adjacent side over the opposite side. Okay, you've probably heard this before. If you go to the top of page 2, a really easy way to remember the 3 basic trigonometric functions, meaning sine theta, cosine theta, and tangent theta, is SOHCAHTOA. Okay, so if you write this out, the S stands for sine. Okay, sine is the opposite over the hypotenuse. Okay, and then the cosine is the adjacent side over the hypotenuse. And then finally, the tangent is the opposite side over the adjacent side. Okay, so just remember SOHCAHTOA to remember sine, cosine, and tangent. And if you have your sine, cosine, and tangent, you can easily get cosecant, secant, and cotangent. Okay. All right, another major thing associated with right triangles is the Pythagorean theorem. Okay, so maybe you know 2 of the sides of your right triangle and you need to get the length of the 3rd side. You're going to use the Pythagorean theorem. A big thing that you've got to remember for the Pythagorean theorem, it's only true for right triangles, okay? So a little later in the course, we're going to study oblique triangles. Oblique triangles are triangles that do not have right angles, okay? There's no right angle in your triangle, and you cannot use the Pythagorean theorem on it, okay? It is only for right triangles, okay? What it tells us is that, again, only for right triangles, a squared plus b squared is equal to c squared. Okay, so a, b, and c, those guys are referring to the lengths of the sides of the triangle. Okay, so basically c is reserved for the hypotenuse like we said. A and b are the adjacent and opposite sides. It doesn't matter which is which. I usually reserve a for adjacent, okay, but that's not a requirement. So basically this is telling us that if you take the length of the adjacent side and square it, and then add the length of the opposite side squared, that's going to give you the length of the hypotenuse squared. Okay, that is what the Pythagorean theorem tells us. Okay, if you know 2 of the sides, okay, you can plug in those 2 sides, and then that will let you solve for the remaining side.